On all of these models, you will have noticed that I've plotted an equator and also, by inference, the poles. This pole data comes from, there's a global, international global database of ancient pole data. The ancient magnetic poles are, without going into too much depth, all volcanic rocks contain minute iron minerals, the magnetites and the hematites crystals, and when they solidify, that magnetite in particular will have a polarity that will have a north-south pole and would be lined up with the ancient pole. So if you then come along and take measurements on these on this remnant magnetism, you can then get an indication of where the ancient pole was. And when you plot all of this information on my models, you get a diametrically opposed north and south cluster, polar cluster, on each and every single model. And from there, it's just simply a very simple process of scaling through 90 degrees to determine the equator. This is the North Pole. It should, by right sequence, through to the present day. That is actually located in Mongolia and North China. You have, that's Antarctica, Greenland, North America, Australia's in here, I think, from memory, in here. Bearing in mind that Australia was north-south at that time, so it's nipping into the northern hemisphere. When you sequence through time, that pole, the actual pole, stays in the same place throughout Earth history. That's one thing that came out of this research. The actual pole, both poles stayed in the same place. It's the actual continents that move around. As the oceans open up and the radius changes, you get in this apparent migration of the continents, an apparent migration of the pole. So the North Pole commenced here, was in Mongolia, North China, for 95% of Earth history, then briefly migrated into Northern America, and then back into the Arctic Ocean where it is at the present. Again, this is the ancient South Pole, and that, what you can see on the screen, is Africa. So this is Africa, again orientated sideways. This is South America, tucked in. The Atlantic Ocean will eventually open up at that join. This is India, Madagascar, and Antarctica, and remnants of Europe up here. So the South Pole was located in Central West Africa throughout 95% of Earth history. As the continents started to break up and the new oceans formed, that apparent polar wander was down through along the west coast of Africa to South Africa, and then during the Mesozoic, which is the era of the dinosaurs, it then migrated across the opening Atlantic Ocean onto Antarctica. Antarctica, bearing in mind, started off in the equatorial regions, and it migrated underneath the pole, underneath the South Pole, and at that time there was a change in climate. So as the pole, this would have had quite a large polar ice cap, and as it migrated south and the Atlantic Ocean opened up, this ice cap was disrupted. As the pole then migrated across the Atlantic Ocean, it became seasonal. With the warm ocean currents, that would have melted that ice cap and became seasonal, hence the change in climate. And once Antarctica started encroaching on the South Polar region, it started to get fixed permanent ice sheets developing on Antarctica for the first time. Antarctica has then subsequently continued to migrate through the South Pole, so we have the South Polar ice sheet concentrically contained within that continent. The change of climates, this media announcements that the South Polar ice cap is melting and we're entering into a change of climate. I don't take much notice of that, because when you consider that Antarctica is migrating underneath the polar ice cap, what happens is that ice cap is, or the continent is trying to drag that ice cap along with it. So what will happen on the leading edge, that will break up and fragment and melt, just exactly what they're showing us on television. But the other side, which we're not showing, will then refreeze and reform. So the ice sheet stays relatively the same size, but it's trying not to be shunted sideways with this continent moving underneath it. And similarly, as it migrated out of Africa, the exact same thing was happening. And when you plot climatic data and distribution of species on there, the same things are happening. And these species are trying to move around, getting away from these changing and evolving climatic zones. Again, what I would have liked to have shown here is the progression of each of these ancient continental seas. The blue outline shown there as the coastlines, and as you change the radius of the Earth and change the configuration of this crust and also the quantity of ocean waters, you get a variation in the coastal outlines. And this, over the period of time, you then progressively evolve from the Rodinia to Gondwana to Pangaean supercontinents and all their subcontinents. And this coastal information was plotted from published information, published readily available global data. There was no manipulation of the data, and it coincided precisely with the distribution of these sedimentary basins, as you'd expect. The sedimentary basins, because material is being flushed into these shallow seas. Moving forward in time, as this crust extends and then finally ruptures and starts to break up to form the modern oceans, you then see in the data a reduction in the area of these continental seas, which implies a draining of these seas into the modern oceans. The formation of the modern oceans, then you then start getting the mid-ocean rift zones opening up, and with the mid-ocean rift zones and the new volcanics, you're getting all this new water being expelled, and as well as the gases, and so you're again getting a flooding and filling up of this modern ocean basins. It's quite dramatic when you see it properly.